So now as alumni, how has your definition of computer science kind of changed or adapted between when you were a student versus now? So Jay, we'll throw it back to you and you can start us off.
Yeah, that's a pretty interesting question, right? We all, I mean, when we are doing as a student, we think of computer science as one way. Oh, I mean, there are these courses, these data structures and algorithms that you need to do, these assignments you need to do, these exams you need to take and everything. So in some way, I wasn't really knowing what the world was out there, like what is the application of those courses or these things what I took. Over years, we have seen this trend in computer science, right, where the application of those things, large-scale distributed systems, are using that to solve artificial intelligence or machine learning type of problems. So that was pretty fascinating to me, like this entire world of how, I mean, at the end of the day, if you look at all these, even if you look at AI, like this neural nets and everything, they are mathematics, and then they are these formulae that you do keep training the same data again and again, and then you are able to detect these patterns and everything. So to me, it's more of taking those subjects what you read and how they are now applied in fields that you can't even imagine. Like every field that you see today has computer science in it. Like you just sometimes we don't even realize it, but that core concepts what you learn is what the entire universe is kind of built with. So that was like kind of a big thing for me from the student to where I am now.
That's awesome. And I'm sure it's cool to like apply those to your everyday job too. It's not just something that you see in a class, like it's more applicable now.
Yes.
All right, Jeff, how about you?
Yeah, I mean, I think Jay hit it. I mean, it basically, what I'd say, I describe it as it went from fringe to mainstream. You know, we were playing with it in this isolation, and here's this box and you work on it. But it was for the nerds. It was not for the mainstream. And like, I come to Microsoft and it is, how do we get Windows to make it be like, it's supposed to be Brad's mom is what we said. Brad was our general manager, and it's got to be simple enough for Brad's mom. And that's one of the earlier steps towards making it more consumer, and from there, phones and everything else. It's just, it's invaded in the best kind of way into every other part of our functioning. So I think it's been awesome to see that progress, to be a part of that.
Chris?
So yeah, I think that we're all agreed on essentially, that concept. I think, when you post the question, a couple of things came to mind, and that is, so back in my time, of course, it wasn't ubiquitous, right? To Jeff's point, and there was no way. We were on a big fax machine, and so everything for us was principles and protocols. So the first thing I would say is, it really is pretty amazing that the principles and the protocols still hold true today. We've done other things with them, but essentially it's still, all the building blocks are all still there and all the same. I think the really big difference is I used to be able to rattle off the ASCII code numerical and binary numbers because you had to have, that kind of an atomic piece to it. But now, because it's so ubiquitous, all of that's already sort of baked in. And so now I think from a university standpoint, any university, they get to actually train what is really needed out in the world, what the working sector is looking for and needing, and they have the opportunity to do that now, versus we were getting those building blocks to be able to go out and try to fit in wherever we were going to go.
Steve?
Yeah, I'm going to kind of take a different direction, because all the technology stuff, of course, is true. I think for me, one of the biggest things is more of a learning that was more personal. When I was at school there, it was like, when am I going to ever write an operating system? When am I ever going to write an assembler? When am I ever going to do a compiler? When am I going to ever do any of these things? And to be honest, 40 some years later, I've done none of them. Okay, so I don't want to play that down, but what I realized, and it took a number of years, and it took actually going back and recruiting on campus computer science majors for 21 years is I learned that it was really about problem solving. You know, how do you approach a problem and put it in all the right buckets, and then you can stand back and look at the technology and say, you know, here's how you layer it on top. And I remember many years the CSRC would have the members meet with the faculty and provide feedback on the courses that we needed. And I remember working with the faculty to get problem solving courses into the curriculum, because you know, that was really critical to me, is that's what we learned is, you know, the techniques you'd learned while writing a compiler, not the compiler itself, but the techniques you learned were really what was important. And you might just take a piece of this and a piece of that and put them all together and come up with something pretty neat, which obviously the industry has many, many times.
You know, Steve, it's so funny that you said that. I had been asked, there was an article that the computer science department had done on me a couple of years ago. And that was essentially the point that I was making is, you know, another part of my job is I do a lot of public policy and political work. And, you know, but you think about project management, I think computer scientists are always like the best project managers, because at the heart of things, they're problem solvers. They get a problem, and then how am I going to walk through it? To your point, Steve, what am I going to pull from to build this thing? I absolutely think that fundamentally moving through your career, I think that's at the heart of it. Exactly.
Yeah, I remember many times I would, you know, I always wanted to go and start writing the code immediately. And that was always a mistake. And when I finally sat back and thought first and then wrote the code, it usually worked one of the first couple times. But every time I just dove right in and wrote the code, I paid the price with many long hours. Yeah, you have to think how to solve it.
It teaches us to break down the problem, right? Break down the problem, approach it in steps. I think that computer science teaches us a lot.
Yes.
They should start the CS course by having everybody watch The Martian. That's like the perfect show, the perfect movie about like work the problem. He said science the shit out of this. It's like, that's totally, you know, everything's going to go wrong and you have to just keep plowing ahead.
And give everybody potatoes.
Right.
Yeah. See what you do by the end of the semester.
That's right.
We might be onto something here.
That's the next course.
Double major, you do your horticulture at the same time, right?
Fall 2021, they'll each get a potato.
I'll make sure that gets up to
I
Cal.
have to survive on it.